You know that feeling when you're just completely swamped by information? Like you see these huge, really critical reports, maybe groundbreaking research papers piling up, and you know they hold vital knowledge, but actually wading through it all, it just feels impossible sometimes. Well, that's exactly the mountain we try to tackle here with the deep dive. We grab that intimidating stack of sources, dive headfirst into the material, and really try to pull out the absolute most crucial, the most eye-opening, and sometimes genuinely surprising insights for you. Today, we're diving deep into a topic that, well, has really moved beyond just an environmental concern into something much more urgent, much more personal. We're talking about the profound and frankly rapidly accelerating impact of climate change, not just on the planet, but directly, undeniably on human health. And these aren't effects way off in the future. We're talking about impacts happening right now, affecting people everywhere in ways that are maybe far more immediate, more widespread, and more severe than you might realize.
Yeah, and this isn't just based on, one single report or one research team's opinion. Our source material for this deep dive is actually a really significant stack of information. We're synthesizing the latest findings from major international bodies, the ones really at the absolute forefront of this research. We're pulling from the World Health Organization's assessments, the core conclusions of the IPCC's most recent sixth assessment report, that's the big one, the comprehensive analysis from the latest Lancet Countdown on health and climate change, which is a vital annual tracker, and also crucial insights from the World Bank. So what we have here represents a really powerful converging scientific and institutional consensus. It's drawing on reports published pretty recently between 2023 and early 2025, and their core message. It's delivered with, well, startling clarity and urgency. These reports tell us, pretty unequivocally, that climate change is no longer some distant environmental problem or just a future threat to health. It is an immediate, active, and rapidly worsening public health emergency. Right now, on a global scale.
A rapidly worsening public health emergency. That's a really stark phrase. It's frankly quite alarming. So, over our time together in this deep dive, we're going to unpack exactly what that means for you, for people around the world. We'll look at the direct physical harm, from things like heat and extreme weather. We'll explore how the changing climate is fundamentally altering where and when diseases actually show up. We'll talk about the hidden but very real and growing mental health toll. And importantly, we'll look at what we can realistically do to build resilience, to protect ourselves and our communities. And crucially, why tackling climate change at its root might actually be the single most important public health action we can take today. Our mission here is to give you those essential takeaways, the critical facts, the most striking figures, those kind of aha moments, so you walk away truly well-informed on this absolutely vital interconnected challenge, this link between the health of our planet and, well, the health of everyone living on it. Okay, so let's unpack this right at the start. The source material makes it abundantly clear, doesn't it?
This isn't something coming way down the road. The impacts are already here, they are severe, and they seem to be accelerating. How big is this crisis right now, according to these reports?
Right. To really get a handle on the scale, the reports collectively frame climate change as something almost insidious. It's not just one new problem appearing out of nowhere. It's described across these major sources as a pervasive health risk multiplier.
A health risk multiplier. What does that mean exactly?
Think of it like this. It doesn't just cause health problems entirely from scratch, although it does that too. But crucially, it takes all the existing vulnerabilities that already exist in the world, things like poverty, ongoing conflict, inequality, limited access to health care, maybe inadequate infrastructure. And when climate impacts hit those places, those situations, they make all those existing problems significantly, dramatically worse. They amplify them. The latest Lancet Countdown report specifically is a really critical piece here. It was published in October 2024, and it's presented as the most up-to-date, comprehensive global assessment we have right now. It tracks this health and climate connection across 56 different indicators. And what they found in this latest assessment was, well, pretty alarming. 10 out of the 15 key health threat indicators that they measure hit disturbing new records.
10 out of 15.
10 out of 15. That's over 2/3 of their core threat indicators showing unprecedented levels of risk, directly tied to the changing climate. It's a very clear signal that things are getting rapidly worse right now. And this lines up powerfully with the IPCC's sixth assessment report from March 2023. That report confirmed what we basically know. The human-induced warming we've already caused about 1.1 degrees Celsius above pre-industrial levels has already driven changes in the climate system that are simply unparalleled in recent human history. And they really emphasize that even seemingly small amounts of additional warming, just another half a degree Celsius, will mean discernible, measurable increases in heat waves, in heavy rainfall events, and in droughts. And those impacts are already widespread and severe across many regions.
Okay, that paints a picture of a crisis that's already active, already widespread. But can we translate that scale into a more human perspective? Can we put actual numbers, projections on the potential human cost of this escalating crisis? People respond to numbers sometimes.
Absolutely. And this is where the reports really hit you with some stark figures. They're summarized in Table 1 of the source material if you want to visualize it. The World Health Organization, for instance, provides some chilling projections just for the near future. They estimate that between 2030 and 2050, so starting just a few years from now and running for the next couple of decades, climate change could cause approximately 250,000 additional deaths every single year.
250,000 extra deaths a year.
Yes, and that's just from 4 specific climate-sensitive causes they looked at: malnutrition, malaria, diarrhea, and heat stress. 250,000 extra lives lost annually just from those 4 things. And beyond that tragic loss of life, there's this massive, potentially crippling economic burden that's already being felt and is projected to grow significantly. The WHO estimates the direct economic damage to health, things like infrastructure damage, treatment costs related to climate impacts, could reach somewhere between $2 to $4 billion per year by 2030. And looking further out, the World Bank's analysis warns that excess health costs, specifically in low and middle income countries alone, could potentially spiral to reach at least US $21 trillion by the year 2050.
21 trillion.
Yeah.
Just in health costs. That number is almost hard to comprehend.
It's staggering. And the reports link this directly to poverty. The World Bank projects that the negative health effects of climate change could push an additional 44 million people globally into extreme poverty by 2030. Yeah, think about that. Millions of people losing their livelihoods, maybe their homes, being pushed into destitution directly because climate change has made them sick or taken away their ability to work or grow food or access clean water.
Billions, even trillions in projected costs. Millions potentially forced into extreme poverty. And those are projections for the very near future. What about the damage and the cost we've already suffered? What do the reports say about the historical toll from extreme weather events that have already happened?
Well, that historical data really provides the foundation for these future projections, and it's equally sobering. It's also laid out clearly in that Table 1. Looking back across 5 decades, from 1970 to 2021, extreme weather events, think floods, storms, droughts, heat waves, were linked globally to around 2 million deaths, and a staggering $4.3 trillion in economic losses.
2 million deaths over 50 years.
Right. And focusing on a more recent period, between 1993 and 2022, the numbers are still immense. Over 9,400 separate extreme weather events resulted in nearly 800,000 fatalities and another $4.2 trillion in economic damages worldwide. What these figures really powerfully demonstrate, I think, is that climate change isn't some abstract concept anymore. These statistics, 2 million deaths, $4.3 trillion lost over 50 years, nearly 800,000 deaths. More recently, they transform abstract ideas like global warming into concrete, alarming realities about human lives lost and economic stability shattered. They show in pretty stark terms that this isn't a distant problem just for future generations. It's an imminent, present challenge that is already costing us dearly, measured in both lives and dollars, and it requires immediate, large-scale action.
And you mentioned right at the start that this burden isn't shared equally. Who is actually bearing the brunt of this already massive and clearly escalating crisis?
Yeah, the reports are very, very clear on the profoundly disproportionate impact. It hits vulnerable populations in specific regions much harder. The IPCC analysis highlights that a staggering number, somewhere between 3.3 billion and 3.6 billion people around the world, live in countries or areas considered highly susceptible to climate impacts.
3.5 billion people. That's almost half the global population.
It is, and they're concentrated in regions like the Arctic, large parts of Central and South America, small island developing states. Those island nations particularly vulnerable to sea level rise and storms South Asia and significant areas of sub-Saharan Africa. And this immediately brings up a really important point. Why are these specific populations and countries so much more vulnerable? It's not random. The reports point directly to pre-existing inequalities. Factors like entrenched poverty, maybe ongoing conflict in the region, limited access to basic resources like clean water and sanitation, already strained healthcare systems. inadequate infrastructure. These pre-existing conditions don't just make people more sensitive to climate hazards when they hit, they also severely limit their capacity to adapt, to recover after an event, or to build resilience for the next one.
So it's not just about the physical geography, where you happen to live relative to a hurricane path or a drought zone. It's critically about your socioeconomic circumstances, your access to resources, the level of existing inequality you face. It's fundamentally a matter of equity and justice, isn't it?
Exactly. It absolutely is. The IPCC provides a statistic that really underscores this starkly. During the decade from 2010 to 2020, mortality rates from storms, floods, and droughts were 15 times higher in countries considered highly vulnerable compared to those countries with very low vulnerability.
15 times high.
15 times. That massive gap in survival rates isn't just bad luck. It's a direct consequence of these pre-existing inequities being ruthlessly amplified by climate impacts. And the World Bank's projection, we mentioned that negative health effects could push 44 million people into extreme poverty by 2030. That further cements this connection. It underscores a profound direct link between climate change, health outcomes, and broader socioeconomic development. It really means that addressing the health impacts of climate change isn't just a medical or a public health task. It's an integral, unavoidable component of broader poverty reduction strategies, of promoting equity and achieving sustainable development globally. The reports consistently emphasize the need for a people-centered approach to climate adaptation and resilience, an approach with a strong focus on social protection systems and ensuring equitable access to resources and opportunities. It needs to be designed for and with these vulnerable populations, not just applied broadly from the top down.
That really sets the scale of the problem very clearly. It's a massive accelerating health threat happening right now with devastating human and economic costs and hitting the most vulnerable people and nations the hardest. It's an urgent crisis by any measure presented in these sources.
Okay, let's dig into some of the immediate physical impacts you mentioned earlier. First up, heat. We all know what a hot day feels like, maybe a heat wave. But what do the reports say about the direct health effects of just rising temperatures and these escalating heat waves?
Well, the reports detail how extreme heat events are escalating dramatically around the world, and this is far beyond just feeling uncomfortable. It's about creating genuinely health-threatening conditions over wider areas and for longer periods than before. The Lancet Countdown report in particular gives us a very concrete, quantifiable measure of this. It found that between 2019 and 2023, so just the last 5 years, people across the globe experienced an average of 46 additional days each year where they were exposed to temperatures considered health-threatening compared to a baseline without climate change.
46 extra days, on average, every year. 46 extra days of dangerously high temperatures on average every year just over the last 5 years. Think about that cumulative exposure and the IPCC projections. They reinforce this alarming trend. They indicate that heat waves that historically might have occurred only once every 10 years are now likely to occur 4.1 times more frequently with just 1.5 degrees C of global warming. And remember, we're already at about 1.1 degrees C, so that's a huge rapid shift in the probability of experiencing dangerous heat.
Wow, 46 extra dangerous heat days on average globally. That figure really sticks with you. What is the direct consequence of that level of increased exposure for our health? What does that do to people?
The consequence is, well, tragically reflected in mortality rates, especially for vulnerable groups. Heat-related deaths have risen significantly. For older adults, specifically those over 65, there was a staggering 167% increase in heat-related deaths recorded in 2023 alone compared to the 1999 baseline period.
167% in 1 year.
Yes. And looking at the average over the last decade, from 2014 to 2023, compared to that same baseline period, the average annual deaths for this age group are up by 106%. These are not small increases. They represent a profound and escalating vulnerability for older populations. And the reports explicitly identify other vulnerable groups beyond the elderly. Outdoor workers, obviously, who can't avoid exposure, young children, individuals with pre-existing chronic medical conditions like heart or respiratory disease, and importantly, those without access to effective cooling like air conditioning. That's a major issue in lower-income communities and naturally hotter climates. Beyond just fatalities, heat exposure also contributes to adverse birth outcomes for pregnant individuals, and it can significantly exacerbate a really wide range of chronic health conditions. The International Labor Organization also flags heat stress as a growing global concern for workers, noting increased risks even in regions that weren't historically accustomed to extreme heat.
That huge disproportionate impact on older adults, that 167% jump in deaths in just 1 year compared to the baseline. It really underscores that point you made earlier about the risk multiplier. Climate change isn't just creating new health problems from scratch, but it's dramatically amplifying existing vulnerabilities, isn't it? Hitting those who are already more fragile the hardest.
Exactly. It absolutely underscores that. And it means that public health interventions related to heat stress cannot be one size fits all. They need to be highly targeted and specifically designed to protect these most vulnerable populations. A general warning or approach just won't be sufficient to address these rapidly escalating and very unequal risks. And beyond the human health crisis, the economic cost of extreme heat is also substantial, as detailed in the reports. Heat increasingly limits labor capacity, particularly for work done outdoors or maybe in uncooled indoor environments like factories or warehouses. In 2023, a record 512 billion potential hours of labor were lost globally due to heat exposure. That figure represents a massive 49% increase compared to the 1999 average.
Half a trillion hours of lost work.
Potential hours lost, yes. And the global potential income loss attributed to this reduced labor capacity from extreme heat reached US $835 billion in 2023. Nearly $1 trillion in potential earnings globally wiped out in a single year by heat stress impacting productivity.
So heat isn't just a direct health threat with tragic human consequences. It's hitting global economies directly by impacting worker productivity on a massive scale. That really strengthens the argument, doesn't it? For investing in heat adaptation strategies, things like cooling centers, maybe urban greening, worker protection laws during heat waves, developing more resilient infrastructure, it makes them not just public health necessities, but clear economic imperatives. It probably costs less to adapt than to lose nearly $1 trillion a year in labor capacity. What about other extreme weather events, the floods, the intense storms, the droughts and wildfires we seem to be seeing more and more of? What are the direct health consequences there, according to these reports?
Well, these events are becoming both more frequent and more intense due to climate change, and their impacts are devastatingly direct. They cause immediate death and injury, of course, but they also lead to illness and significantly worsen existing medical conditions in their aftermath. As we touched on earlier with the overall statistics, over the 3 decades between 1993 and 2022, more than 9,400 such extreme events resulted in nearly 800,000 fatalities and that $4.2 trillion in global economic damages. The IPCC reports note that since 2008, extreme floods and storms alone have led to the displacement of over 20 million people annually from their homes worldwide.
20 million people a year displaced.
Every year, on average, since 2008. Just imagine the disruption, the trauma, the immediate health needs when 20 million people a year are suddenly forced from their homes, often with little warning. And then there are wildfires, which are intensified by higher temperatures and prolonged droughts linked to climate change. They're a major enduring threat. The risk of wildfires and human exposure to them increased in 124 countries between the periods of 2003-2007 and 2019-2023. And the smoke inhalation from these massive fires isn't just an irritant. It's directly linked to severe respiratory conditions, reduced lung function. It contributes to acute and chronic heart issues like heart failure, heart attack, and stroke. And it's a documented cause of premature death. It's a very clear pathway from environmental change, drought, and heat to serious life-threatening health problems. And while droughts fuel fires, we're also seeing more intense rain events on the other side of the coin. The Lancet Countdown notes that a record 61.3% of the global land area experienced an increase in the average number of extreme precipitation days per year in the latest decade compared to the 1961-1990 baseline. More intense rain means higher flood risk, which brings its own cascade of health issues.
So, beyond the immediate physical harm, the injuries and deaths directly caused by the events themselves, what happens to people's health in the aftermath of these extreme weather events. What are the secondary impacts the reports highlight? Because those can last a long time, right?
Absolutely. There are significant and often very long-lasting secondary risks that have major health consequences, and these can sometimes be overlooked in the immediate chaos of response. Displacement from homes, as we mentioned, is a huge one. Being forced to leave your community, your home, your usual healthcare providers can severely interrupt access to essential healthcare services. It makes it incredibly difficult to manage existing chronic conditions like diabetes or heart disease or mental health issues. Evacuations themselves pose specific health risks, especially for vulnerable individuals like older adults or those with disabilities. It's often complicated by the critical need to transfer medical records, ensure continuity of care, and maintain access to necessary medications. You can't just stop taking insulin during an evacuation. What these reports consistently highlight, though, is while the physical injuries, the structural damage, the immediate deaths are tangible and often the focus of media coverage and initial response, the psychological toll of extreme weather events is equally profound and can be incredibly long-lasting. Research cited indicates that the emotional impacts from events like hurricanes or floods can persist for months, even years, after the physical event has passed. This leads to serious and debilitating conditions like post-traumatic stress disorder, PTSD, acute stress disorder, generalized anxiety, disruptive behavior, and tragically even increasing the risk of suicidality, particularly among children who experience these traumatic events and the subsequent disruption to their lives.
That really highlights something crucial. Disaster response needs to integrate robust, long-term mental health and psychosocial support as a core component right from day one. It can't just be about physical aid and rebuilding infrastructure.
Exactly. It needs to be built in from the start and sustained. And the interconnected nature of these events, as the source points out, is also critical to understand. Storms can trigger floods and landslides, while droughts and high temperatures can trigger or significantly increase the severity and spread of wildfires. This reveals a complex cascade of risks, where one event can initiate a chain reaction of compounding health threats that are far more challenging for health systems and communities to manage than isolated incidents might be. This implies that climate risk management and health adaptation strategies need a more sophisticated, multi-hazard, integrated approach. We need to anticipate how different types of extreme events might interact and occur in combination, for example, a heat wave followed by a flood, or drought leading to fire and then subsequent landslides when rains return. It means not just addressing floods or fires in silos. This requires much more sophisticated planning and flexible, coordinated response mechanisms across different agencies and sectors, emergency management, health, infrastructure, social services to protect populations effectively.
That's a really comprehensive look at the immediate physical impacts. And let's just quickly reference Table 2 from the Lancet Countdown, which is mentioned in the source because it really pulls together many of these points visually, doesn't it? It summarizes these key direct threats, confirming those alarm bells. 10 out of 15 health threat indicators at new records globally. We see those striking stats on heat exposure again, that average of 46 extra days of dangerous heat, that shocking 167% increase in heat-related deaths for older adults, and the massive 512 billion potential labor hours lost globally due to heat. It also points to the widespread impact of drought, affecting nearly half of global land area in 2023, and the significant increases in areas experiencing extreme precipitation days, raising flood risks. And crucially, it starts to hint at other threats we'll discuss next, like food insecurity and those alarming disease shifts, including the rise in vector-borne and waterborne diseases like vibriosis, hitting record cases. It really brings together how interconnected all these direct environmental changes and resulting health threats are, and how the science is tracking these shifts in tangible, measured ways. Okay, so moving beyond those immediate direct physical impacts like heat and floods, how is climate change fundamentally altering where and when certain diseases occur? It sounds like it's actually redrawing the map of global health threats in real time.
It absolutely is. Climate change is actively reshaping the epidemiology, which is, the study of where and when diseases happen of both infectious diseases, like those carried by mosquitoes or ticks, and increasingly non-communicable diseases too, through complex pathways we're only just starting to fully grasp. The environmental shifts driven by warming are creating new, sometimes surprising opportunities for pathogens, viruses, bacteria, parasites to transmit and proliferate in places they weren't historically seen, or maybe at times of the year they weren't previously a problem.
Let's start with those vector-borne diseases, the ones spread by insects or ticks, like malaria, dengue fever, Zika, or Lyme disease. How are they being impacted? This seems like a major area of concern.
It is. Rising temperatures and altered precipitation patterns are the key drivers here. The reports outline some complex mechanisms, but the overall effect is pretty clear. They make environments more suitable, more hospitable for these vectors and the pathogens they carry. So warmer temperatures are directly expanding the geographic range where vectors like mosquitoes and ticks can survive and breed. This allows them to move into previously inhospitable areas, including higher elevations that used to be too cold for them. The source mentions tropical disease-carrying ticks surviving winter months in Germany as a very concrete, striking example of this range expansion happening in, unexpected places. Simultaneously, these improved climatic conditions due to warming are extending the duration of disease transmission seasons. That means diseases can potentially be spread for more months of the year in many regions.
So they can live in more places and for longer each year.
Exactly. And temperature changes can also alter the vector's behavior. For instance, increased temperatures might change how frequently mosquitoes bite, or perhaps what times of day they are most active, which obviously impacts transmission dynamics. And importantly, higher temperatures accelerate the life cycle of both the vector and the pathogen living inside it. The source notes that higher temperatures speed up mosquito larval development, meaning they grow from egg to adult faster. They promote reproduction, they enhance blood feeding frequency, they increase digestion rates, they actually shorten the mosquito's overall life cycle in some cases, and can even lower mosquito mortality rates. The net result: larger, more numerous, and ultimately more efficient disease-spreading vector populations. Furthermore, and this might seem a bit counterintuitive at first, both increased rainfall and prolonged droughts can paradoxically create more standing water, which provides additional breeding grounds for various vectors, depending on the specific species and the local environment.
How can both more rain and less rain do that?
Well, heavy rain can leave puddles and fill containers, obviously, but drought can dry up larger bodies of water like rivers or ponds, leaving behind smaller, isolated pools. These smaller pools can actually be ideal breeding sites for certain mosquitoes because they lack the natural predators, like fish, found in larger water bodies.
Okay, so the environment is becoming more hospitable for the vectors. The vectors themselves are becoming more numerous, maybe more effective spreaders, potentially changing their behavior, and doing it for longer periods of the year and in new locations. That sounds like a perfect storm for wider disease spread.
It's precisely that, a convergence of factors favoring disease spread. And the global burden from this is already immense. Mosquito-borne diseases alone are responsible for over 1 million deaths, and an estimated 700 million infections annually worldwide, even before these climate change accelerations really kicked in. The specific trends highlighted in the reports are particularly alarming, and they demonstrate the rapid shifts already underway. For dengue fever, which is a rapidly spreading viral infection, the climatic suitability for its transmission by the two main mosquito species, Aedes albopictus and Aedes aegypti, increased significantly between the baseline period of 1951-60 and the recent period of 2014-23. That suitability jumped by a striking 46.3% for Aedes albopictus and 10.7% for Aedes aegypti. Those are huge increases in the potential area where dengue can be transmitted.
Almost 50% increase in suitability for one type of mosquito.
Yes, it's a massive expansion. And the historical warming we've already experienced has already contributed to an estimated 18% increase in dengue incidence in specific high-risk areas like the Americas and Asia. And the projections for the future are even more concerning. They suggest a potential global increase in dengue transmission potential of 40–57% by mid-century, and potentially an increase of up to 200% in dengue risk in some localized areas as conditions become optimal. The risk is clearly expanding geographically into previously unaffected areas and seasonally, meaning it's a threat for more months of the year. For malaria, which remains a massive global health challenge, particularly in Africa, an additional 17.1% of global land area became suitable for malaria transmission between that same 1951-60 baseline and 2014-23. We saw malaria cases rise from 227 million in 2019 to 241 million in 2020, with most fatalities still tragically occurring in Africa among vulnerable groups, particularly young children. The accelerated parasite and mosquito life cycle due to heat is considered a significant contributing factor to this recent rise and makes control efforts harder. Beyond dengue and malaria, other diseases are also expected to spread into new territory. Zika virus exposure, for instance, could affect an additional 1.3 billion people globally by 2050 as warmer temperatures render more environments suitable for its mosquito vectors. Even Lyme disease, a tick-borne illness predominantly known in the USA, is projected to see over a 20% increase in cases with just 2 degrees C warming, with the tick season starting earlier in the spring and lasting longer into the fall.
That's a lot of dangerous diseases on the move, expanding their reach and becoming more prevalent. What's particularly interesting here is the source specifically mentions a nonlinear relationship for dengue transmission, with peak incidence occurring around a specific temperature, noted as 27.8 degrees C. Can you explain what that means and why it's important? It sounds like it's not just hotter is worse.
Yes, that's a really critical and often counterintuitive nuance, and it's vital for understanding how to predict and respond to these disease shifts accurately. A nonlinear relationship means the effect isn't a simple straight line. It's not just warmer always equals more dengue everywhere. There seems to be an optimal temperature range for these specific mosquitoes and the dengue virus they carry to thrive and transmit most efficiently. The source notes the optimal range is around 29 degrees C for Aedes aegypti and a slightly cooler 26 degrees C for Aedes albopictus. So what this means is that small temperature rises in currently cooler regions, regions that are below that optimal range, can have a dramatic outsized impact on disease spread because conditions suddenly become much more favorable, pushing them into that sweet spot. But conversely, if an area that's already hot gets significantly hotter and actually exceeds this optimal temperature range, transmission might eventually decrease there. It might become too hot even for the mosquitoes or the virus development. This could potentially shift the burden elsewhere, maybe to slightly cooler zones that are now entering the optimal range.
So it's about hitting that sweet spot temperature-wise.
Exactly. This suggests that our predictive models and our public health interventions for vector-borne diseases absolutely must account for these nonlinear dynamics. Strategies need to prioritize regions where temperatures are shifting into that optimal range for vector proliferation and pathogen development, rather than just assuming a uniform increase in risk everywhere that gets warmer. It points to a really complex future where the map of disease suitability will constantly be redrawing itself based on these specific temperature thresholds, region by region. And this range expansion into entirely new areas, like those ticks surviving German winters or mosquitoes, showing up at higher elevations in mountainous regions fundamentally shifts disease geography. This puts populations who have no prior exposure and therefore no acquired immunity at risk for diseases they've never had to deal with before. It means healthcare systems in these newly affected regions need to urgently prepare for diseases they haven't historically encountered. This requires developing new diagnostic capabilities, maybe adapting treatment protocols, launching targeted public health campaigns to educate both the public and healthcare workers about new risks. And it critically underscores the need for improved disease surveillance systems, surveillance that can track not just where the disease cases are occurring, but also the evolving geographic distribution of the vectors, the mosquitoes, the ticks, and the pathogens themselves. This allows for proactive public health responses rather than just reacting after an outbreak has already started.
It really does sound like a whole new map of disease distribution is being drawn by the changing climate, bringing old and new risks to new populations. What about waterborne illnesses? How does climate change affect those, especially since you mentioned earlier that both floods and droughts can increase risk? That still seems counterintuitive.
It does seem counterintuitive, but climate change, through its impact on the hydrological cycle, intensifying evaporation, allowing the atmosphere to hold more water, contributes to a rise in both extreme wet events like heavy rain and floods, and more severe, prolonged droughts in other areas. The reports indeed highlight this kind of heads I win, tails you lose dynamic for water safety. Both hydrological extremes significantly increase waterborne disease risk, often just through different mechanisms.
Okay, explain that again. How can both too much water and too little water make the water riskier to drink or swim in?
Right. Well, heavy rainfall and floods can overwhelm municipal sewer systems and wastewater treatment plants, especially in places with aging infrastructure. This can lead to the discharge of raw or inadequately treated wastewater, which is laden with pathogens like bacteria and viruses, directly into rivers, lakes, and coastal waters. Those might be the very sources used for drinking water downstream or for recreation. Floods also cause massive runoff from agricultural areas, washing animal waste, fertilizers, pesticides, and pathogens like E. coli off fields and into water sources, potentially contaminating drinking water wells and surface water intakes. The sheer volume and force of floodwaters can also physically damage water treatment plants, taking them offline entirely when they're needed most.
Okay, that makes sense for floods overwhelming the system. What about drought?
Conversely, droughts deplete water sources, rivers shrink, lakes recede, groundwater levels drop. This reduction in the total volume of water effectively concentrates any pollutants and pathogens that are already present in those remaining water bodies. So while there's less water overall, the number of pathogens per liter of water can increase significantly, potentially reaching levels that exceed the capacity of existing water treatment facilities to effectively disinfect and remove them before the water reaches people's taps. Less water also means less dilution for any new pollutants or pathogens that might enter the system, like from agricultural runoff or leaky septic systems. And adding another layer of risk on top of that, warmer water temperatures, which are a direct consequence of global warming heating up lakes, rivers, and oceans, directly boost the survival rates, the virulence, meaning how dangerous they are, and the growth rates of many waterborne pathogens. Think of bacteria like Legionella, which causes Legionnaire's disease, and various Vibrio species, which include the bacteria that cause cholera and other nasty gastrointestinal illnesses called vibriosis. The reports note that the majority of studies reviewed show a clear positive association between rising temperatures and the incidence of diarrhea caused by bacterial pathogens. Warmer water essentially acts like an incubator, and we're already seeing this manifest in the data. Historical outbreaks linked to water contamination events often involved Vibrio and Leptospira. More recently, vibriosis cases, those bacterial infections often contracted from eating raw or undercooked seafood or swimming in contaminated coastal waters, hit an estimated record high globally in 2023, reaching around 692,000 cases.
Wow, nearly 700,000 cases of vibiosis.
Yes, and this surge is largely attributed to hotter coastal waters, making conditions much more favorable for Vibrio bacteria to thrive and multiply in shellfish and the water itself. The risks of cholera outbreaks, already a major global health problem, are also expected to rise significantly with higher average temperatures, increased heavy rainfall events, and associated flooding facilitating its spread. Even warmer lakes can promote the proliferation of toxic algal blooms, specifically certain types of cyanobacteria. These blooms produce powerful toxins that can affect the nervous system, respiratory system, or liver if ingested, and cause severe skin rashes just from contact during swimming.
So whether there's too much water from floods, too little water from drought, making things concentrated, or just warmer water letting bacteria thrive, the risk of getting sick from waterborne illnesses goes up. It really does feel like a trap where climate change creates multiple pathways to contamination, hitting water safety from all angles.
Exactly. It's a multi-pronged assault on water safety. And again, predictably, nations and communities with limited sewer infrastructure, inadequate water treatment facilities, and already strained public health systems are disproportionately affected by these diseases. Children are particularly susceptible, partly due to their behaviors like playing in potentially contaminated water and their developing immune systems. And this raises an important practical challenge highlighted in the reports. A significant issue here is that waterborne disease symptoms, things like nausea, vomiting, diarrhea, stomach cramps, often look very similar to the symptoms of very common foodborne illnesses. This frequently leads to underdiagnosis and underreporting of the true burden of climate-linked waterborne diseases. Cases might just be classified as generic gastroenteritis or stomach flu without identifying the specific climate trigger, the water source, or the pathogen involved.
So it becomes a kind of hidden burden of disease, basically.
Yeah.
We don't necessarily know how much of this common illness is actually being driven by climate impacts on water.
Yes, precisely. And this underreporting hinders effective public health response and resource allocation. If you don't accurately track and attribute these illnesses to climate-related water changes, you can't effectively target interventions like upgrading specific water infrastructure, improving watershed management, or implementing timely early warnings for water contamination events. There is a critical need, highlighted in the sources, for improved surveillance systems, enhanced diagnostic capabilities in labs, and targeted public awareness campaigns to accurately track and attribute these illnesses to climate-related environmental changes and ensure we mount the appropriate, most effective responses.
Okay, let's shift to respiratory illnesses. Air pollution seems like an obvious link here, and you touched on wildfire smoke earlier. But is there more to it than just climate change worsening existing pollution sources?
Air pollution is indeed a major and escalating threat, and it's heavily intertwined with climate change. It was responsible for a massive 8.1 million deaths globally in 2021, making it the second leading risk factor for mortality worldwide, right after high blood pressure. The reports highlight that fine particulate matter, known as PM2.5, largely from the burning of fossil fuels for energy, transport, and industry, causes over 90% of these air pollution deaths. Climate change does intensify existing pollution patterns through things like creating stagnant air masses during heat waves that trap pollutants near the ground, and it introduces new sources. Wildfire smoke, definitely exacerbated by heat and drought, is a clear and growing example, directly linked to severe respiratory conditions and cardiovascular issues, as we discussed. However, recent research highlighted in the source points to a novel, perhaps less intuitive, and frankly quite fascinating mechanism by which global warming might be exacerbating lung diseases. It has to do with air dryness, specifically measured as high vapor pressure deficit, or VPD.
Air dryness. That sounds really surprising. How could simply breathing drier air directly harm our lungs? It seems so subtle.
It is subtle, but the mechanism proposed is genuinely fascinating. A study published in March 2025 from researchers at UNC, cited in our source, explains it, and it's quite elegant biologically. It turns out that breathing in these increasingly common dehydrating atmospheres, which are becoming more prevalent due to climate change's impact on humidity and temperature patterns, can directly inflame human airways, independent of pollutants.
How does that work?
Well, our airways are lined with a protective layer of mucus. Normally, this mucus is a dilute gel-like substance that traps inhaled particles and pathogens, and it's then cleared away efficiently by tiny hairs called cilia. But under conditions of high VPD, which essentially means the air is very thirsty for moisture, like when you're breathing rapidly through your mouth in low humidity air, or breathing very warm, dry air indoors or out water, evaporates rapidly from this mucus layer. The researchers describe this process as remarkably similar to transpiration in plants, where water evaporates from leaves into dry air. This evaporation concentrates the mucins, which are the large molecules that give mucus its structure, making the mucus layer thinner, stickier, and much harder for those tiny cilia hairs to effectively clear from the airways. It becomes less lubricating and more obstructive. And here's the critical health link. This physical change in the mucus layer, this compression and irritation of the epithelial cells lining the airways caused by the altered mucus consistency, acts as a sufficient stimulus on its own to trigger a local inflammatory response right there in the lungs. This inflammation then directly exacerbates pre-existing chronic respiratory conditions like asthma and chronic obstructive pulmonary disease, COPD, making symptoms worse or triggering flare-ups.
So it's not just pollutants in the air that are the problem. The fundamental physical properties of the air we breathe, specifically its dryness, are changing in a way that directly harms our lungs by messing with our body's own defense mechanisms. That's really quite something.
Precisely. It's a mechanism that goes beyond the well-established effects of inhaled air pollutants like PM2.5 or ozone. It reveals a more intricate biological response to environmental changes triggered by warming. And it's likely made worse by factors like chronic mouth breathing, which is often associated with conditions like obesity, nasal allergies, or even just aging and increased exposure to dry indoor air from central heating or air conditioning systems, which also tend to lower humidity. Vulnerable populations, including the elderly, young children, and potentially impoverished groups living in poorly insulated homes with less humidity control, are likely particularly sensitive to these climate-induced respiratory risks from dry air. This new understanding potentially points to new areas for intervention, maybe focusing on strategies to maintain airway hydration, perhaps through nasal breathing techniques or targeted humidification, or developing treatments to counteract the specific inflammatory responses triggered by this dry air exposure. It also highlights the need to consider indoor air quality, specifically humidity levels and lifestyle factors like breathing patterns, as important cofactors in climate health assessments. So while air pollution from fossil fuels and wildfires are readily recognized as obvious, major respiratory threats, the impact of air dryness or high VPD suggests that even subtle chronic shifts in ambient atmospheric conditions, not necessarily tied to acute extreme events like a wildfire, can have profound and widespread physiological effects on human respiratory health. This truly expands the scope of climate health impacts beyond just acute hazards to include these more pervasive, long-term environmental changes that affect us literally every time we take a breath. This understanding implies that public health monitoring might need to broaden its scope to include parameters like VPD, and climate models should perhaps refine their projections of atmospheric humidity changes to help us better anticipate and address this less obvious but potentially widespread health threat.
That's a really eye-opening example of how climate change works in these subtle, unexpected ways that we're only just beginning to fully understand through cutting-edge research. Finally, let's talk about something incredibly fundamental. How does climate change impact food security and basic nutrition? This seems critical.
It poses formidable and escalating obstacles, threatening the very foundation of human sustenance globally. Shifts in average temperature and precipitation patterns, coupled with the increasing frequency and intensity of extreme events like severe droughts, floods, and heat waves, directly threaten crop yields, livestock health and productivity, fisheries, and also the integrity and functioning of global food distribution networks. The reports highlight just how widespread this is already. In 2023 alone, nearly 50% of the global land area was affected by at least 1 month of extreme drought. That's half the planet's land surface experiencing severe water stress that directly impacts food production potential.
Half the land area. Wow. And what are the consequences for people?
The consequences for global food security and nutritional outcomes are severe and escalating. The reduction in crop yields and disrupted supply chains directly contributed to an additional 151 million people experiencing moderate to severe food insecurity in 2022 that can be directly attributed to climate change impacts. That's on top of existing hunger. But critically, the problem isn't just about there being less food overall, quantity-wise. Climate change also directly impacts soil fertility, influences the viability of staple crops in different regions, reduces overall yield, and crucially, it alters the composition and bioavailability of nutrients within the foods that are grown. This means that the food that is produced and available often contains fewer essential macro and micronutrients, things like protein, zinc, iron, vitamins, compared to the same crops grown under pre-climate change conditions.
So it's not just a question of less food on the table globally, but that the food that is available is becoming fundamentally less nutritious, less able to provide the vitamins and minerals we need for basic health.
Exactly. It's a double whammy. Less food and less nutritious food. And poor diet is already a major cause of mortality and illness globally. Approximately 690 million people were experiencing chronic hunger before these climate impacts significantly worsened. That number is projected to surpass 840 million by 2030, further exacerbated by climate change pressures on food systems, and predictably, marginalized populations and vulnerable regions, particularly in sub-Saharan Africa and South Asia, are disproportionately impacted by these compounding food security and malnutrition challenges. The research also highlights what's described as a deeply concerning vicious cycle here. Current mass food production practices things like intensive fertilizer use, deforestation for agriculture, expanded livestock production. Long supply chains contribute significantly to greenhouse gas emissions and thus directly to climate change itself. This in turn worsens climate impacts like droughts and floods, which then further reduces food production and availability, leading back to more food insecurity and malnutrition, potentially requiring even more intensive high-emission practices to compensate. It's a dangerous feedback loop.
A self-reinforcing negative cycle.
Exactly. This self-reinforcing loop means that sustainable solutions to food insecurity in the context of climate change have to be holistic and transformative. They can't just focus narrowly on adapting crop resilience to hotter conditions or less water, though that's important. They must also fundamentally reform agricultural practices to be sustainable and actively reduce emissions across the entire food system from farm to fork. It fundamentally calls for a widespread transformation of global food systems, moving beyond incremental adjustments to embrace comprehensive, sustainable approaches that break this cycle of harm. And the impact on nutrient quality, leading to what's sometimes called hidden hunger, where populations might consume enough calories overall but still lack essential micronutrients, is particularly critical and often overlooked in food security discussions. Even with enough overall food quantity, populations may face significant micronutrient deficiencies due to climate change impacting the nutritional content of staple crops. This can severely exacerbate morbidity, impair child development, and have serious long-term health consequences for entire populations. So, food security interventions must evolve beyond simply addressing caloric deficits to ensure comprehensive nutritional adequacy. This requires significant research into and development of climate-resilient, nutrient-dense crops and the promotion of diversified farming systems that can better withstand environmental changes while reliably providing the essential nutrients needed for healthy diets.
Table 3 here in the source, it gives a fantastic summary of these complex disease links we've just been discussing. Vector-borne, waterborne, respiratory, foodborne. It clearly lists the climate drivers, the specific mechanisms like that mucus transpiration effect in respiratory health or pathogen concentration in drought-affected water, concrete examples like dengue suitability increasing by that huge 46.3%, or the record vibriosis cases linked to warmer coastal waters, and observed trends like malaria suitability expanding into new areas. It really brings together how deeply interconnected all these different environmental changes and resulting health threats are, and how the cutting-edge science presented in these reports is tracking and measuring these shifts in disease landscapes in very concrete ways. Now, this next part of the crisis is perhaps less immediately visible than a flood or a heat wave, maybe less tangible, but potentially just as devastating in its impact: the significant and growing mental health burden of climate change.
Absolutely. This is a critical dimension. Climate change has profound and escalating psychological consequences, impacting mental well-being through multiple distinct pathways. The reports describe these pathways in detail, and they're helpfully outlined in Table 4 of the source material. First, you have the direct acute impacts. These come from immediate personal exposure to climate-related extreme weather events and disasters, actually experiencing a hurricane, surviving a wildfire, living through a severe flood, maybe enduring a prolonged, dangerous heat wave. This direct exposure can cause significant trauma, shock, intense anxiety, and acute stress. It can directly lead to conditions like post-traumatic stress disorder, PTSD, acute stress disorder, major depression, generalized anxiety disorder, and tragically, even increasing the risk of suicidality in the aftermath. The trauma isn't just from the event itself, but also from the devastating consequences like being displaced from your home, losing cherished belongings, fearing for your life, or maybe the tragic loss of loved ones. And secondly, there are the indirect chronic impacts on mental health. These arise more slowly through the long-term alteration of social, economic, and environmental conditions caused by climate change. This includes things like prolonged displacement from homes and communities, the loss of livelihoods due to climate impacts on agriculture, fishing, or local industries, and chronic exposure to food and water insecurity. All of these ongoing stressors contribute to sustained psychological distress, chronic anxiety, feelings of hopelessness, and depression. Long-term exposure to fluctuating extreme temperatures, both very high and very low, can also influence mental health outcomes and affect mood and cognitive function over time. And finally, and this is perhaps the most broadly impactful pathway, especially in developed nations maybe, there are the perceived or vicarious impacts. These arise simply from the awareness or observation of climate change and its consequences, even if you are not directly experiencing an extreme event yourself right now. The perceived threat of climate change, just the knowledge of its potential for devastation, seeing its ongoing impacts globally through the media, and the profound uncertainty it creates for the future can induce significant anxiety, pervasive fear, grief over environmental losses we see happening, worry about future generations, frustration at perceived inaction, and a profound sense of powerlessness in the face of such a massive global crisis.
This perceived threat pathway, leading to this sort of constant background hum of worry and anxiety. That sounds like something many of our listeners, particularly those who are well-informed and engaged with this topic, might very well be experiencing in their daily lives. It resonates.
Yes, absolutely. And it's a pathway that the reports formally acknowledge and for which the mental health field is actively developing specific language and understanding. This awareness of the environmental crisis, the ongoing degradation, and the potential for future catastrophe has given rise to specific psychological constructs that are now being formally studied and recognized in the literature. Terms like eco-anxiety, which is that chronic, often debilitating worry about the environmental future. Ecological grief, which is the sadness and mourning over the loss of ecosystems, biodiversity, or familiar landscapes changing irreversibly. And solastalgia, which is the specific distress caused by negative environmental change to a place one feels deeply attached to or considers home. The source material formally mentions these terms, reflecting a maturing understanding within the psychological and public health fields that these are distinct, clinically relevant experiences directly tied to the environmental crisis and the existential threat posed by climate change.
Eco-anxiety, ecological grief, solastalgia, these terms really capture specific feelings, don't they?
They do. And this growing recognition and formalization reflects that these aren't just generic stress responses. They are specific psychological conditions directly tied to environmental degradation, loss, and the existential threat of climate change. This evolution in terminology signifies that the mental health field is developing a more nuanced framework to address these unique challenges. Consequently, mental health professionals and public health systems require specialized training and resources to effectively diagnose, understand, and treat these climate-specific mental health conditions. It also strongly implies that policy frameworks must explicitly acknowledge and integrate mental health considerations into broader climate action plans, moving beyond just focusing on physical health impacts because the psychological toll is clearly immense, widespread, and growing. Other specific psychological consequences and mental health conditions linked directly to climate change indicators in the reports include increased rates of depression, anxiety, and suicidality, which are associated with chronic climate stressors like long-term drought or economic disruption. Elevated temperatures in particular have been correlated in some studies with increased psychiatric hospital admissions for a range of mental and neurological disorders, including dementia, mood disorders, anxiety disorders, schizophrenia, and bipolar disorder. There is also evidence of an increased mortality risk for individuals with pre-existing psychiatric disorders during heat waves, especially among older people and women who may be less able to thermoregulate or access cooling. And, as with the physical impacts, certain vulnerable groups are especially susceptible to these mental health burdens. This includes individuals with pre-existing mental illness whose conditions may be exacerbated by the added stress. Indigenous peoples whose cultural identities, spiritual practices, and overall well-being are often intimately tied to specific lands and ecosystems undergoing dramatic climate change. Migrants and refugees displaced by climate impacts who experience profound loss, trauma, and uncertainty. And importantly, children and adolescents who are grappling with the reality of an uncertain environmental future and may lack the fully developed coping mechanisms of adults. Children, for example, have been documented in studies to show signs of PTSD and other significant psychological disturbances for months, even years, after exposure to traumatic events like hurricanes and the subsequent disruption to their homes, schools, and communities. What's particularly emphasized in the research presented here is While acute trauma from experiencing an extreme weather event is a readily apparent mental health consequence, we absolutely cannot overlook the profound impact of the chronic stressors that go beyond that immediate trauma. These include things like, as the source puts it, loss of land, flight and migration, exposure to violence sometimes associated with resource scarcity or displacement, change of social, ecological, economic, or cultural environment, and also that pervasive perceived threat of climate change that so many people feel hanging over them. These ongoing, often insidious stressors contribute significantly to the cumulative mental health burden over time, leading to chronic conditions that require sustained support, not just immediate crisis intervention.
So interventions really need to encompass both the immediate trauma response after a climate disaster and actively address these ongoing, often less visible pathways of psychological distress that affect people over months and years. It implies needing strategies for fostering community resilience, providing comprehensive psychological and social support for displaced populations long-term, and maybe even developing coping mechanisms and support structures specifically for the existential anxieties associated with climate change, alongside traditional trauma care.
Precisely. The mental health field globally must prepare for the significant and growing burden that climate change will inevitably place on population health and well-being in the long term. Table 4 in the source material clearly maps out these different pathways. The direct, the indirect, the perceived. It lists the specific psychological consequences and conditions being observed, and it identifies the particularly vulnerable populations. It really shows the multifaceted and deeply complex nature of this significant challenge. It's not just about people feeling worried. It's leading to documented, diagnosable conditions on a large scale.
Okay, given the immense scale and the complexity of the crisis we've discussed, the escalating direct impacts, the shifting disease landscape, this growing mental health burden, what can actually be done? How can we start building real resilience in our health systems and in our communities to cope with these escalating threats that are, well, already here?
Yeah, that's the critical question. Strengthening health system resilience and implementing effective, widespread adaptation strategies are paramount, as highlighted throughout these reports. This isn't really optional anymore. It's presented as essential for protecting populations now and in the future, and it involves multifaceted interventions, everything from infrastructure changes to policy reforms.
What does that look like specifically for the physical health infrastructure? Hospitals, clinics, emergency services. How do they become more resilient?
Well, fundamentally, it means ensuring that essential health services can continue operating during and immediately following climate-related extreme events, even when facing major challenges like utility outages, no power, no water, transportation disruptions making it hard for staff and patients to get there, or even direct physical damage to buildings. Health organizations and planners must proactively anticipate these climate risks for their specific locations. Are they prone to floods, heat waves, wildfires? And then build infrastructure that can actually withstand the anticipated climate events, often needing to go beyond standard, historically based building codes, which might not be adequate for future conditions. Specific strategies cited include constructing critical health facilities like major hospitals, emergency centers, public health labs with sustainable and resilient communication systems, not just relying on the grid, backup energy like solar with battery storage, secure water supplies, and robust waste infrastructure. Ideally, these critical facilities should also be sited in locations chosen specifically to minimize exposure to anticipated climate events like floods or extreme heat. For less critical facilities, maybe smaller clinics, the planning should focus on ensuring protocols for safe closure before an event hits, and having clear practice plans for a rapid resumption of services within a defined time frame, typically aiming for 48 to 96 hours afterward, to minimize disruption to care. The source provides some examples of innovative approaches already being implemented around the world that can serve as models. Nigeria's development of mobile clinics specifically designed to reach flood-affected zones when roads are impassable. India's investment in solar-powered hospitals to maintain critical functions like refrigeration and lighting during power outages caused by extreme weather. And incorporating eco-friendly features like rooftop farms or extensive green spaces in U.S. hospitals that can help with urban heat island mitigation locally and improve stormwater management around the facility itself.
These types of initiatives, like solar power or green roofs on hospitals, sound like they address both climate resilience and potentially contribute to reducing the environmental impact of healthcare itself simultaneously. Is that right?
They absolutely do, and that's a key synergy identified in the reports as critical to leveraging investment effectively. What's really compelling here is These types of initiatives, installing solar power, improving energy efficiency in buildings, implementing on-site water storage, or recycling in healthcare facilities, can both lower healthcare's own significant carbon emissions and directly support service continuity and resilience during climate shocks. So decarbonizing healthcare isn't just about reducing its environmental footprint, though that's important too. It's presented as a fundamental part of building a more resilient, more reliable health system that can actually function when climate shocks inevitably hit. This dual benefit transforms climate action within the healthcare sector from potentially being seen as just another cost or a regulatory burden into a clear opportunity for systemic improvement, for greater efficiency, and ultimately for enhanced public health outcomes. Policymakers and funders should therefore prioritize these climate-smart healthcare investments that offer these clear dual advantages, maximizing the return on investment for both environmental sustainability and crucial public health resilience. A truly holistic approach to resilient infrastructure also needs to incorporate broader urban planning strategies around healthcare facilities, things like investing in green infrastructure nearby, supporting heat island mitigation measures in surrounding neighborhoods, using reflective surfaces, increasing tree cover, adding green spaces, and enhancing community-wide stormwater management system to reduce flood risk around these essential facilities. It really requires a multidisciplinary effort, bringing together everyone from facilities managers and security personnel to engineers, sustainability officers, and clinical care providers all working together.
Okay, so building physical resilience into the infrastructure is key. What about warning people before these events hit? Are early warning systems effective in a rapidly changing climate? Can they keep up?
Early warning systems, EWS, are highlighted across the reports as indispensable tools for building resilience and safeguarding lives and livelihoods. And the reports underscore their proven effectiveness. They are considered among the most cost-effective climate change adaptation measures available globally. They offer a remarkable return on investment, potentially up to tenfold, according to some analyses. The source notes that simply providing a 24-hour advance warning for certain climate hazards, like a major storm or heat wave, can potentially reduce the resulting damage by up to 30%. That's a huge impact from just timely information.
A tenfold return. That's impressive.
It is. Heat health early warning systems, HHWS, are a specific example of this effectiveness. They typically combine meteorological forecasts for high temperatures and humidity with local health data and vulnerability assessments to provide graded alerts, maybe an advisory, a watch, or a full warning that trigger specific pre-planned public health interventions. These interventions can include things like opening public cooling centers, distributing water, conducting targeted outreach to known vulnerable populations, like the elderly living alone, or issuing broad public health advisories with heat safety tips through media channels. Some studies cited in the source demonstrate significant reductions in heat-related deaths directly attributable to HHWS implementation, ranging from a 17% to a striking 51% reduction of expected fatalities during heat waves in some cities, saving an estimated 2.6 lives per day during one studied heat wave period. For these systems to be truly effective in a climate that is rapidly changing and throwing new combinations of hazards at us, they increasingly need to be multi-hazard in nature. That means they need to account for multiple potential risks and their interactions, for example, warning for a heat wave that might then be followed by heavy rain causing flash floods or a prolonged drought increasing wildfire risk significantly. This multi-hazard approach is crucial in a changing climate where events can trigger these complex, cascading impacts we discussed earlier. However, this raises an important question and a challenge highlighted in the reports. Despite their proven effectiveness, many existing EWS are often designed based primarily on historical climate conditions and past patterns of vulnerability. They rely on patterns from a climate that is already fundamentally different from the one we're experiencing today, and certainly different from the one we're heading towards.
So they might be calibrated for yesterday's weather, not tomorrow's. They need to be dynamic and adaptable themselves, constantly being updated as the climate continues to shift.
Exactly. The source explicitly states they should have flexible structures and processes to support modifications as climate and development baselines shift. This requires continuous research, real-time monitoring of both climate trends and health outcome data, and an adaptive capacity built into the system itself to recalibrate alert thresholds and response measures based on evolving climate data and also changing population vulnerabilities as demographics shift or infrastructure changes. This necessitates ongoing, close interdisciplinary collaboration among meteorologists who predict the weather hazards, public health experts who understand the health impacts and vulnerabilities, and social scientists who understand community contexts, communication needs, and how people actually respond to warnings. And there's a critical, significant gap identified in the reports related to EWS coverage, the very limited inclusion of mental and psychosocial health risks in most health early warning systems globally. One report noted that only 10% of countries reported having health EWS that specifically included mental health considerations in 2023, compared to 35% that had systems in place for heat-related illness.
Only 10% cover mental health. Given the significant and growing mental health burden we discussed earlier, that disparity seems like a really significant and concerning oversight in global preparedness efforts. It feels incredibly urgent to research, develop, and build mental health indicators and support into these early warning systems.
Absolutely. It highlights an immediate need for targeted research into what appropriate indicators for climate-related mental health distress might even look like. How do you reliably trigger an alert for psychological risk across a population? And then dedicated funding to develop and implement these systems, ensuring that psychological vulnerability and mental health service needs are integrated into comprehensive climate risk assessments and response plans from the outset.
Okay, so beyond infrastructure and warning systems, how does policy and actually empowering communities fit into this broader strategy of building resilience?
Integrating health considerations explicitly and strongly into broader national and international disaster risk reduction (DRR) policies is presented as crucial for building comprehensive resilience. This involves several things: establishing health-centric risk governance frameworks, making sure health is at the table when DRR decisions are made, ensuring that health risks are systematically incorporated into data monitoring and early warning systems right from the design phase, and strengthening the health aspects of post-disaster recovery efforts, making sure that the concept of build back better explicitly includes making health systems and community health infrastructure more resilient than they were before the disaster. There has been some positive progress on the policy front in recent years, it's worth noting. The number of countries conducting dedicated climate change and health vulnerability and adaptation VNA assessments increased significantly, from just 11 countries reporting doing so in 2022 to 50 countries in 2023. So that shows a growing recognition, at least, of the need to formally assess these links. However, a significant policy disconnect remains starkly evident when you look at countries' actual climate action plans. The reports note that only 47% of the nationally determined contributions, NDCs, those are countries' official climate action pledges under the Paris Agreement submitted in 2023, actually referred to health at all. Less than half.
Less than half even mention health.
Yes. And perhaps even more concerning, government mentions of the link between climate and health in their high-level statements during the UN General Debates, which is a key global political platform, also declined notably, falling from 50% of countries mentioning it in 2022 down to just 35% in 2023.
So the science is sounding louder alarm bells than ever. More countries are doing assessments. But overall, the actual policy commitments and the political prioritization on the global stage don't seem to be fully catching up to the urgency of the health crisis being described.
That's precisely the critical disconnect highlighted repeatedly in these reports. And alongside top-down policy, empowering communities with locally led adaptation efforts is also presented as absolutely key. These bottom-up initiatives are crucial because they foster solutions that are tailored to specific local needs, cultural contexts, existing capacities, and unique vulnerabilities that might be missed by national plans. This could mean things like adapting traditional farming practices to changing rainfall patterns based on local knowledge, developing community-based strategies for managing water sources and preventing cholera outbreaks during floods, or setting up neighborhood-level heat shelters run by local volunteers. Addressing the health disparities we talked about fundamentally means adopting inclusive approaches that actively prioritize marginalized groups, children, women, indigenous peoples, displaced populations, people with disabilities in policy development, in funding allocation decisions, and in the design of disaster management systems, ensuring their unique vulnerabilities and needs are specifically addressed. Now, what's particularly striking and identified as a major barrier to scaling up effective adaptation is, despite the recognized importance of all these adaptation efforts, there's a critical lack of rigorous quantitative studies evaluating the actual effectiveness of specific health adaptation interventions, especially in low and middle income countries where many vulnerable populations live and where resources are most constrained. The source refers to this as a significant deficit of studies. This is identified as a major systemic problem because without robust evidence on what works, where, and for whom, it's very difficult to identify which specific strategies are the most effective, the most cost-efficient, and the most equitable. This lack of evidence hinders evidence-based policy and investment decisions. We can't easily compare the costs and benefits of different potential adaptive actions across various sectors to inform smart resource allocation.
So we know adaptation is needed, but we don't always have the hard data on which specific actions give the best results.
In many cases, particularly in resource-limited settings, yes. And funding gaps persist, exacerbating these challenges and limiting the ability to scale up even the interventions we do think are effective. The reports highlight the truly stark contrast between record global fossil fuel subsidies, $1.4 trillion in 2022 alone, actively driving the problem, and the very limited funding available for adaptation. Only a fraction, just 27% of total global adaptation funding identified, went specifically to the health sector in 2023. And perhaps even more critically, less than 17% of total adaptation finance actually reaches the local levels, despite the acknowledged importance of local actors in implementing actions and understanding local needs.
Less than 17% gets to the local level.
That's what one report indicated, highlighting a major bottleneck. The declining government mentions of health in global climate discussions and the low health references in national climate pledges, NDCs, directly contradicts the escalating scientific evidence and urgent warnings coming from bodies like the WHO and the Lancet Countdown. This points to a need for much stronger mechanisms for translating knowledge effectively from the scientific community to policymakers. This could involve targeted advocacy, capacity building for government officials on health-climate links, and developing accessible, actionable recommendations that clearly articulate the immediate health imperatives and co-benefits of climate action. There's also a critical data blind spot identified specifically by the World Bank report. Millions of young people around the world are losing valuable learning days due to climate-related events, whether it's school closures from floods, heat waves, storms, displacement, or even just lack of safe water at school, yet this loss of educational access isn't systematically tracked globally. This represents a significant, largely unquantified loss of human capital impacting future earnings potential, productivity, and overall societal well-being, which is currently being underestimated in most climate impact assessments. We urgently need robust, systematic data collection on these indirect but profound societal impacts of climate change, like educational disruption, to truly understand the full costs and to design recovery and adaptation efforts like building back better schools effectively.
Okay, so clearly adaptation is crucial for dealing with the impacts that are already locked in and getting worse, but ultimately to really address this crisis at its core, we have to address the root cause, the greenhouse gas emissions, driving climate change in the first place. The source material talks extensively about how climate mitigation, actually reducing those emissions, has profound and immediate public health benefits. It's not just about the environment.
Absolutely. This is a central theme across all the reports. They consistently present climate mitigation efforts not just as an environmental necessity to protect the planet in the long run, but fundamentally, and perhaps more immediately, as a massive public health intervention with significant, direct, and wide-ranging co-benefits for human health and well-being right now around the world. A critical area for intervention identified across these reports is redirecting finance. The reports are very direct, very unambiguous about this. Record fossil fuel subsidies, continued extensive fossil fuel production, and escalating global energy demand, much of it still met by fossil fuels, are pushing emissions to dangerous levels, actively endangering human health today, and exacerbating health inequities globally. The Lancet Countdown explicitly calls for a rapid and equitable transition away from fossil fuels. They argue for shifting trillions of dollars currently spent supporting fossil fuel production and consumption towards investing in a net zero economy. They state this is necessary to prevent catastrophic harm to billions of people worldwide. Current projections highlighted show that major oil and gas companies are on track to exceed their share of emissions consistent with limiting global heating to 1.5 degrees C by a staggering 189% by the year 2040 if current plans continue. And as we mentioned, a net $1.4 trillion in fossil fuel subsidies were allocated globally in 2022 alone.
So continuing to fund, produce, and subsidize fossil fuels is presented in these reports not just as bad environmental policy, but is actively undermining global health inequity while simultaneously fueling the climate crisis. That's a strong statement.
Yes, the reports frame it in precisely those terms as a fundamental contradiction between current economic policies and stated global health goals. It's seen as continuing to exacerbate health inequities and diminish the chances of achieving the climate stability necessary for global health security. On the flip side, aggressively decarbonizing sectors that currently rely heavily on fossil fuels offers huge, measurable health gains, often almost immediately, primarily through cleaner air. Take the healthcare sector itself, for example. While it contributes significantly to global emissions through its energy use, supply chains, anesthetic gases, etc., the Lancet report highlights a really critical finding. They found an association between a country's healthcare emissions per capita and higher life expectancy only up to a certain point, around 400 kilograms of carbon dioxide equivalent, CO2e, per capita. Emissions beyond this threshold were not linked to better health outcomes in their analysis.
That's a really provocative and profoundly important point, isn't it? Healthcare emissions above a certain level aren't actually making people healthier or live longer, according to this analysis, but they are significantly contributing to the climate change that harms health in so many other ways we've discussed. It's a direct paradox right within the health sector itself.
It is indeed a striking paradox, and it provides a strong internal mandate, a justification from within, for the healthcare sector itself to aggressively pursue decarbonization, especially in high-income countries. High-emitting countries with advanced healthcare systems, such as the U.S., which has estimated healthcare emissions significantly over 1,600 kilograms CO2e per capita, way above that 400 kilogram threshold, can likely significantly decarbonize their healthcare sectors without compromising the quality or access to care provided. The UK National Health Service, NHS, provides a compelling model and analysis of this potential. Their publicly stated decarbonization strategies are estimated to yield substantial health benefits in addition to reducing their own environmental footprint. By 2040, their plans are estimated to save roughly 5,770 lives per year just from reductions in air pollution associated with their energy use and transport changes, and potentially another 38,400 lives per year saved through increased physical activity resulting from associated transport changes for staff and patients.
Wow, tens of thousands of lives saved just from the health co-benefits of decarbonizing the health system itself.
Yes. It's a clear example of a major health system aiming to optimize both health outcomes and environmental performance simultaneously, leading by example on the potential co-benefits.
What about transitioning to clean energy across the board, outside healthcare, and promoting sustainable transport like walking, cycling, and public transit? What are the health co-benefits there?
These offer some of the most substantial and immediate health co-benefits alongside huge economic returns in many cases. Transitioning from fossil fuels to renewable energy sources like solar and wind directly reduces air pollution, particularly PM 2.5 and nitrogen oxides, which, as we discussed, is a massive global killer. In the U.S., for instance, the increase in solar and wind tower generation between 2005 and 2016 led to the avoidance of 147 metric tons of CO2 emissions in 2015 alone. But crucially, this clean energy transition is estimated to have avoided somewhere between 3,000 and 13,000 premature deaths in the U.S. just between 2007 and 2015 simply due to cleaner air. The shift also provided significant economic benefits from avoided healthcare costs and lost productivity, estimated somewhere between U.S. $30 billion and over $100 billion over that period.
Huge health and economic benefits from clean energy.
Exactly. Promoting sustainable transport also offers huge health gains, often through two main pathways: increased physical activity from walking and cycling, and reduced air and noise pollution from fewer cars on the road. In New Zealand, a program promoting cycling and walking not only cut transport emissions, but also yielded an estimated NZ$11 in health benefits, primarily from reduced rates of obesity, heart disease, diabetes, etc., for every single NZ$1 spent on the program. That's an incredible 11-to-1 return on investment, mostly through health savings. Tokyo's program encouraging businesses to adopt low-emission vehicles cut 440,000 tons of CO2 from participating businesses, contributing to cleaner air in the city. Improvements in household energy efficiency, like upgrading insulation and heating systems in low-income houses through Australia's Healthy Homes program, resulted in lower gas use, reduced emissions, decreased energy bills for residents, and directly improved health outcomes, including reduced reports of breathlessness and better self-reported mental health due to living in warmer, healthier homes. This consistent evidence across different sectors, different countries, different types of interventions that climate mitigation actions yield clear environmental benefits, plus significant measurable health improvements, plus often tangible economic gains through avoided costs and increased productivity, strongly aligns with the concept often referred to as a triple dividend. Framing climate policies not just as environmental regulations or costs, but as integrated public health strategies and economic development opportunities can be a really powerful way to overcome political inertia and mobilize broader public and political support and investment. The evidence presented across these reports is overwhelmingly clear. Acting decisively on climate change is incredibly good for our collective health, our individual well-being, and very often our economies too. The benefits far outweigh the costs.
Okay, before we wrap up this deep dive, let's just quickly summarize the key challenges the reports highlight that are hindering effective action, pulling together some points we've touched on throughout. What are the main roadblocks?
Right. I think the biggest overarching challenge identified, particularly for adaptation, is arguably that significant lack of rigorous quantitative research evaluating the effectiveness of specific health adaptation interventions, especially in low and middle income countries where vulnerabilities are highest and resources are most scarce. We need many more robust studies to definitively know what specific strategies work best in different contexts, for which populations, where, and at what cost, to guide evidence-based investment effectively. Funding, as we discussed, remains a major persistent hurdle. That stark contrast between record ongoing fossil fuel subsidies, $1.4 trillion, and the very limited adaptation finance available, especially the tiny percentage that actually makes it down to the local levels where implementation happens, is a significant barrier to making necessary changes at the speed and scale required. And critically, there is that persistent and concerning gap between the overwhelming scientific evidence about climate change as an escalating health crisis and its full, urgent integration into global and national policy and political action. The decline in government mentions of health in major climate discussions, the low reference rate in national climate pledges, these are worrying indicators of this disconnect. We need better data collection systems, like systematically tracking those lost learning days due to climate events, and much stronger, more effective mechanisms for translating complex scientific knowledge into clear, compelling, and actionable policy recommendations that policymakers can understand, adopt, and actually implement. Bridging that science policy gap is crucial. So to summarize this whole deep dive, the evidence from this wealth of authoritative converging reports is clear, it's undeniable, and it's incredibly urgent. Climate change is not a future problem or just an environmental issue. It is an accelerating global health crisis affecting everyone right now in fundamental ways. It's altering where and when dangerous diseases occur, it's increasing direct physical harm from extreme heat and weather events, and it's taking a significant and growing toll on mental well-being worldwide. And critically, it is disproportionately impacting the most vulnerable populations among us, ruthlessly exacerbating existing inequities.
But the crucial, maybe empowering message that these reports also deliver, the good news, in a sense, is that climate action is fundamentally health action. Mitigation efforts aggressively cutting greenhouse gas emissions by transitioning away from fossil fuels towards clean energy and sustainable systems offer massive, immediate, and measurable health benefits, particularly through cleaner air and healthier lifestyles. And investing in resilient health systems, strengthening early warning systems that account for the changing reality, and implementing locally led adaptation measures are critical, often cost-effective steps for protecting populations from the impacts we can no longer entirely avoid.
Exactly. Addressing this crisis effectively requires integrated global action across all sectors. It means explicitly putting health and equitable health outcomes at the very core of all climate policy decisions, not treating it as an afterthought or a side benefit. It requires a fundamental redirection of finance away from harmful fossil fuels towards health-supporting clean energy and adaptation initiatives. It demands strengthening health systems globally to be climate smart, resilient, and prepared for the challenges ahead. It necessitates improving data collection and surveillance systems, including urgently for mental health impacts, to truly understand the burden and track progress effectively. It requires fostering strong collaboration across sectors and disciplines: health, environment, energy, agriculture, finance, urban planning. It means investing strategically in research to identify the most effective interventions. And it means empowering communities, particularly the most vulnerable, with a clear focus on equity and local needs in all adaptation and mitigation efforts.
Delayed action on climate change is undeniably costing lives and livelihoods today, as those striking statistics on deaths, poverty, and economic loss clearly show. And it will continue to do so, likely increasingly rapidly, if we don't change course dramatically. A rapid, fair, integrated response, with human health and equity as the central driving force and guiding principle, is not merely an option or a recommendation from these reports. It's presented as an urgent necessity, critical to safeguard the health and well-being of current and future generations. So drawing from all these insights, all this data, what does all this mean for you listening right now? How do you process this information, this profound connection between the climate crisis and our health, our family's health, our community's health?
Well, this raises an important question, doesn't it? A question that really sits at the heart of these reports and maybe requires some collective reflection. Considering how deeply climate change is already woven into our health, our economies, our social structures, even our psychological well-being, how can we collectively move beyond viewing it solely or primarily as an environmental problem, often seen as separate from us? How do we truly embed health and the urgent need for equitable health outcomes for all people as the central driving force, the compelling reason why, the primary motivation for taking rapid, transformative, and decisive climate action starting right now?
That's a powerful question to end on, and one that really reframes the entire conversation around what's most important, doesn't it? It gives a clear, human-centered purpose to the urgent need for climate action. Thank you for joining us on this deep dive into the escalating global health crisis driven by climate change. We hope it gave you some valuable insights, clarified the urgency, and perhaps offered a new perspective on this absolutely critical issue.